Now let's look at the hyperbola. The general form for the equation of a hyperbola centered at the origin, again we're going to center things at the origin for the hyperbola and the ellipse, is x squared over a squared minus, that's the difference, minus y squared over b squared equals 1. So we'll still go a distance horizontally from the origin, a. Under x, the horizontal axis, will go a. And the distance vertically from the origin to the point on the hyperbola will go as b. Under y, vertical axis, will go a distance b, not b squared. Note that the vertices on the hyperbola are determined by the positive term. Doesn't matter which one's larger, a or b. It matters which one comes first, which one's positive, and the other one is negative. So the wings go to the person who's positive. Let's look at an example of that. If we had x squared over 4 minus y squared over 9 equals 1. In the x direction, we'll be going 2 from the origin in both directions. And in the y, we'll go a distance of 3. So we'll go up vertically 3 and down vertically 3. Now the difference with this equation is that it's a minus. So it's not the ellipse, it's not the circle, it's the hyperbola. And so when I have those points in the x direction and in the y direction, what I do is not make a circle, I make a box. I make it with all these little negative signs. And that's kind of how I think about it. If it has a negative sign in the problem, then I just make a whole bunch of little negative signs. Then when you go through the corner of the box, the exact corner of the box is what we call asymptotes. And that's these dotted lines. And asymptotes help you to guide where the wings of the hyperbola go. Then you still have to figure out who gets the wings. Did the wings go up here or are they going here on the side? And it all depends on which one's positive. And since our x is positive, we went to the end of our box for the x-axis and we attached on the wings. Let's try and do that again with this equation. Y squared divided by 16 minus x squared divided by 1 is equal to 1. So again, we want these all to equal 1. We're going to start with the numbers that are added to the x and the y, which is 0. And then in the y direction, we're not going to go 16, but we're going to go 4. 1, 2, 3, 4. And also 4 in the negative direction. Then in the x direction, we're going to go 1 to the right and 1 to the left. And then this is like an imaginary box. And so the box is not important for anything other than its corners. You need the corners of the box so that you can draw the asymptotes. And the asymptotes go right through the corner of the box, through the center of your graph in both directions. So that's just supposed to be a guide to help you understand where the graph is going. Asymptotes are something that you approach, but you never get there. Now, for the last thing is the wings of our hyperbola. So we look to see which one is positive. Our y is positive. So at the end of the y direction is where we're going to attach on the wings of our hyperbola. And I call them wings because I refer to a hyperbola actually as a hyperbird who's got wings flapping all over the place. And there you have it. Okay, again, this one's not quite in the right form. It's supposed to equal 1. So if we divide each term in the problem by 25, and yes, I'm actually dividing and not multiplying by 1/25, we will have x squared over 5 minus y squared over 25 is equal to 1. That all-important 1. So what's added to the x and the y is nothing, so we're starting at the origin, 0, 0. In the y direction, we're going to go the square root of 25. In the y direction, we're going to go 5 up and 5 down. Now what's interesting is in the x direction, we're not going 5, we're going to go the square root of 5. So again, you may want to put this in your calculator to see what the square root of 5 is, and it's about 2.2. So in the x direction, I'm going to go 2 and a little bit, and 2 and a little bit to the left. Now again, all that's really important from putting in these points is the corner of the box. The corner of the box will tell you where the asymptotes must go through. So I'm just going to put in those corners, and then I will draw the asymptotes. Okay, and now who is the positive term is x. X came first, he was positive, y is negative. So here at the end when I went in the x direction, that actually is where my wings are going to be attached. And they will jut out and try and approach the asymptotes. They'll never touch them, but they'll get forever, ever closer. So it appeared to me that the wings were just blending in too much, so I went back and made them in black so you could see them easily. And there is how you graph a hyperbola. Now remember, the hyperbola is the one that has subtraction. Circles and ellipses both have pluses, and your parabola only has one exponent 2.